Hello, I'm Tom Wilson. I'm the SOMAS instrument engineer and part-time, I am the Flax Pond facility manager, along with Steve Abrams, who is the Flax Pond curator and laboratory manager. We are going to talk today about the Flax Pond Preserve and laboratory. First, we'll start with the Flax Pond Preserve. It is located in Oldfield, New York, which is only 3 miles north of the main Stony Brook University campus. The preserve was acquired by New York State in 1966 and is administered by the New York State Department of Environmental Conservation, DEC. Total area of the preserve is 152 acres, which is 0.6 square kilometers. It includes an estuarine embayment, the pond, Flax Pond, a salt marsh, and some upland forest. The laboratory building was built in 1969 by New York State. It is operated by Stony Brook University in a long-term lease agreement with DEC. The lab includes running seawater laboratories, a greenhouse, a wet chemistry lab, cold room, a research office, classroom and meeting space, an atmospheric chemistry lab, and shop space. It has been renovated and expanded several times through the years. The most recent renovation is underway from 2019 through this year, and over $5 million has been spent already on that renovation. Through the decades, Flax Pond has done groundbreaking research on seaweeds, on shellfish, with finfish, and on aquaculture. And to sort of show how groundbreaking some of it is, the picture in the lower right of this slide of silver sides, also known as Menidia, was taken by Flax Pond curator George Rowland some years ago. And that picture was the cover picture in the journal Science on the week that our former dean David Conover published his work on forced evolution in finfish. We also do education and outreach. We have educational programs, both formal courses and educational outreach at the primary, secondary, and university levels. And now I'll turn it over to Steve to talk about the current state of the renovations. Go ahead, Steve.
Well, thank you, Tom. As you can see, this is a rough floor diagram of our laboratory. The laboratory originally was about 9,000 square feet. We have added a little over 928 square feet for a total of about 10,000 square feet. Of this area, we've got now 7 wet labs with running seawater and floor drains. The areas that have been improved are in the light green. The addition to the building is the blue color in the front of the building. We have added a brand new hatchery, which is on the lower right. We have an algae culture and chemistry laboratory, which is in the blue color area in the front of the building. We have a greenhouse that's 960 square feet that has heat and running seawater in it, so we can grow algae. We've done a number of ambient temperature studies in that particular room. We have a brand new pump room, and we have added improvements throughout the entire building. All the electrical has been completely upgraded, as have all the floor drains and sewer system for the entire building. This is our new generator. It's approximately 250 kilowatts. It is capable of running all the seawater pumps, air conditioning, and heat in the building. So in the event of power outages, we are capable of running for at least 10 days on its internal fuel tank. And we can borrow fuel from the tank next door. The building will not suffer in the least in any kind of power weather situation. This is our brand new pump room. As you can see, it's rather complex and filled with all sorts of interesting things. For the view on the upper right, those are our bag filters that will filter down our seawater to approximately 5 microns as needed. On the bottom is just a quick shot on the right of all of our seawater circulation pumps for the building. There are also 2 boilers in there to heat ambient seawater to whatever temperatures we need. The middle photograph has the sand separators, the small canisters with the red tops to remove any kind of silt that's in the ambient water as it's coming in. But perhaps the most important thing is on the upper left, we have a complete monitoring system that checks flow rate, temperature, salinity, all sorts of different parameters. And if something should go wrong, it will both email and text myself, Tom, and anybody else who's designated on that call list. It will check and give us accurate real-time measurements of anything that's going on in the lab. And most importantly, with all of those pumps, we have redundancy. Every single circulatory system in the building, which provides both heated and unheated, ambient and filtered seawater, has a backup. So when one pump is taken out for service, there is no interruption in service in the building or quality of water for the organisms being studied. This is our 12,600 gallon head tank. It is going to be filled at all times with circulating seawater. The water gets filtered if it needs to be and pushed through that head tank. It allows us, in the event of some catastrophic emergency, such as the pond filling in or freezing over, that we will be able to run at least 3 days off of that head tank with fresh seawater to keep all of the experiments viable. And we have done this before and it works extremely well. This is our brand new renovated hatchery. It's 1,260 square feet. As you can see, there are multiple drops to provide filtered and unfiltered seawater, and both forms of seawater can be heated. The large pipe is an air distribution system, which is powered by one 1 horsepower blower with another 1 horsepower blower as a backup. So there's never a concern about running out of air, compressed air. We have multiple GFCI power cords for safe use of chillers. Each one of those is capable of providing 20 amps of power to whatever equipment you need. The floors are, of course, waterproof and sterilizable, and the floor drains are brand new. The lighting is dimmable from very bright in banks to very dim if you need to do different types of research. And of course, there are shades on the windows for photoperiod research. The lab itself is swipe card protected, which means there's very limited access to only the people who need to do research. And that gives a high level of security to both the laboratory and to that particular room. These are our 2 new laboratories in the front end of the building. That was that light blue area on the diagram. On the right is an algae starter culture lab. It is built specifically to keep small samples of algae, but can also be used to keep small marine organisms. Both of these labs have running seawater and floor drains. The lab on the left is going to be our new chemistry lab. It's going to be available for any types of water quality, algae growth, any other type of research that that we can provide. All the outlets in there are waterproof and water resistant, so you can bring in a number of different types of equipment. And those labs are also secure, protected by swipe card access only. So again, experiments and equipment that are in that lab are perfectly safe. This is an aerial view of Flax Pond. The dotted line represents where our new seawater lines are going to be put in underground. They will be 4 feet below the marsh to protect them from freezing, as the pond does freeze occasionally. Each of those seawater lines will be 8 inches in diameter, and they are redundant, so one line can provide seawater while the other line is being serviced. The little blue rectangle at the top of the picture is where our 100-foot long floating platforms will be. The seawater intakes will terminate there. We will have flupsies for the growth of different types of shellfish, and other types of cage aquaculture can be performed on that platform. There will be a high voltage electrical line running out there, so there is plenty of power for water quality monitoring, which we do hope to have a station out there. But for any kind of air blowers or any other type of experiment, there is plenty of power at this point in time.
So to summarize, when completed, Flax Pond is going to be a really outstanding facility for meeting future challenges in the environmental sciences. Steve and I thank you for your time today, and we really look forward to assisting educators, researchers, and students in converting the many opportunities that are out there into accomplishments with the help of the facility at Flax Pond. Thank you very much for your interest, and hope to see you up at Flax soon.